Well, good morning, everyone. Thank you for joining our presentation. I'm from MistServer. I am Erik. I'm a software engineer. My colleague Jaron, who would actually be doing this presentation, unfortunately couldn't make it here, so I'm standing in for him. I'm going to talk to you a little bit about end-to-end latency on media delivery over OTT. So, first thing, naming the beast by its horns. We have, from the broadcast perspective, have a lot of customers that are actually staying away from the OTT because we have some latency issues there. Getting the actual content to the people is a hassle, and making sure that everyone sees the same thing at the same time can be a bit tedious. So there are various factors in this, and I will name a few of them. To begin with, it's the network itself. Well, you have, we have internet, and we got pretty fast internet as well right now. There's still the question of whether your viewers in Europe will get the same stream at the same latency as the ones that are in the US, or whether those in Asia get the same bandwidth as well. Or streaming to the rural areas, the network might not be as good as you would like. Making sure that your viewers will get a subpar experience there. We can put some servers, some more. You can place your CDN network on tactical spots, get some more bandwidth up and running, but that's not all you can do about it. We got some protocols, so we can stream to various devices over various methods, and all of them have some benefits, some drawbacks. For example, UDP, it's really fast. It's the way to go if you want to do low latency, but you got some packet loss. You got hampering connections whenever something only a little bit is wrong with the connection. You get jitter on your images. You get subpar visual quality. Well, there are some techniques out there like BRT or SRT or Dozer that do some forward error correction and make sure that the content is still viewable on the other side. It's still kind of a hard problem to tackle, but latency-wise, that's the way to go. TCP-based true streaming over RTMP, for example, is another good way to go. It has some more latency, but it mitigates the instability features of the UDP streams. But unfortunately, it's flash-based, and as we all know, flash is going to be extinct in the next couple of years. Then we got some pseudo-based streaming, which is basically a file being progressively streamed. By exploiting the functionalities of these kind of things, you can do live streams there, but it's not. It works in most places, but it's not actual streaming, you know. And then we got some segmented streaming where we can get some latency up to 15, 30 seconds because we have to generate the fragments anyway. We can get those down easily by using some features of the protocols, but still you have the segments and you can't get a lower latency than the size of 1 or 2 segments. Now we can go to the technology that is being used. When you do, for example, the segment generation, when you generate your segments, you boost them to a CDN, and you can get your latency keeps building up based on the latency of the CDN itself, the throughput through the CDN, and you can actually go up to over 30 seconds, minutes, to hours even if things go really wrong. And that's where we come in. What we do is we do media streaming from the CDN in a different way. What we do is we do on-the-fly packaging. So we get a stream in, and we wrap it at the moment that a user is actually asking for the stream, making sure that the segments get delivered as soon as we have them available as well. We need to keep a buffer for that, and we can usually do some, usually that introduces latency, because, well, we have to build the segments, we still have to do that, right? And we can actually have some disk-based things there as well, some temporary storage if you're using that kind of solutions. What we've been doing for the last couple of months is reducing these buffers that we have to use. So we can actually go now to up to or down to 2 frames latency, one on the input side, one on the output side, sending them out, going down to about 80 milliseconds. By using some lock-free shared memory structures, so we can have the same data available to all of the output protocols at the same time, the moment it is actually being ingested. We went we used to do the chunk-based protocols, so we used to do the segments, and we're now doing actual packets, so that's frame-based buffering. And we can do optimizers on the various protocols. So for example, if we simulate a live stream using fragmented MP4, we can make sure that when there is a gain in latency to be gained, we can jump forward in the stream without players noticing or having to do anything for that. And by using more of those kind of things, you can actually reduce latency down to a couple of seconds. So what we think you should do to actually reduce your latency overall as your service, you shouldn't go for one protocol. You should go for multiple ones and pick the best ones that are available for each of the various outputs. For example, the Apple devices still only do HLS. We can bring that down to 5 to 10 seconds. But where you can gain a better latency, you're wanting to do that. So why limit yourself to HLS if on other platforms, fragmented MP4, for example, is a better solution? And by exploiting these capabilities and making sure that we handle the weaknesses in the best way possible, you can actually get quite far. And of course, we always will have to be innovative on this. We are working on WebRTC, which should get the 80 milliseconds latency all the way down to basically any browser. There are improvements being made on all of the specs for the different protocols to handle latency in a better way. So that's what the industry as a whole should be doing as far as we think. So that's basically what I was here to talk about. If you have any questions, feel free to ask them now or to come by our booth. We're right there in the back. And thank you for your time.